Hi everyone, I hope I'm audible and visible. Just give me a quick yes if you can hear and see me. Give me a quick yes. Oh, awesome. Welcome to today's session for the BEP course. What we're going to talk about today is how to create an asset. Now, that's obviously going to be a little complicated, so please pay very careful attention. Let me just quickly share my screen with you. I hope this blue screen is visible to all of you. And what we had done the last time was we had set up our own chain and then we looked at the various kinds of permissions that can be given to an address. So today we are going to go to the next step where we are going to create our own asset. Now, step one, when we want to create an asset, because we are talking about a permission blockchain, we need to first identify which address can actually create assets. So it basically has a permission called as issue. Of course, these permissions are also given by whoever is maintaining or administering the blockchain. So here, as you can see, I ran a command called list permissions issue, which means which are all the addresses on this chain which have the issue permission. So this permission. So it's given me one address here. Now, after that, I run another one which is called list addresses. This shows me all the addresses on this chain and it tells me whether or not the private key of that address is available here on this node. So an address is suitable if it appears in the output of the first as well as the second, and in the second it appears with the is mine as true. So we've identified this particular address, this starting with 1W, that's the one we are going to use to issue the assets. Later, we can transfer the assets to this one, which starts with 16. So for now, I just want you to remember this simple thing that we are going to use 1W to create and we are going to use the 16 one for receiving. Now, one of the first things that we need to see is that what command are we going to run to create this asset and what are the various kinds of parameters that we can build into it. Now, those of you who are familiar with, say, an EVM chain like Ethereum, so there you use Solidity and you create a complex contract which defines your asset and how it is going to behave under different circumstances. Now here, because we're using multi-chain which is forked from Bitcoin, this is not EVM compatible. It has its own method of creating assets. And it's actually, to be very honest, a lot simpler. So the first thing that I'm going to show you is, give me 1 second and let me change my screen. Okay. So what are the kind of things that we are going to talk about? So when we create, we call it issue. So first we need to say who is issuing this. So we need an address which has issue permissions and we are going to issue from that address. The next is who are we going to issue to? Now one option is we issue to an other address which has that permission to receive, or a better option usually is issue it to yourself. So suppose we are issuing from the 1W, we issue to 1W also. So a new asset gets created and remains in that same address, and then we can slowly distribute it to others. So that's the most common option that we choose. So we are going to take the same address in issue from and the same in issue to. Then we are going to give a name to the asset. So this name can be about 32 characters and you can put in symbols and other things, there's no problem. That's not the only way you will identify. In once we create an asset, it also gets its own reference ID number. So we can use three things to call an asset: the name that we can set, the reference ID generated by the blockchain, and thirdly, the transaction ID in which it was created. I'll show you all this in a few minutes. Then we can set a permission whether it is open or closed. Open means can we issue more units in the future? So if we say true, then in future we can issue more units. If we say false, then we cannot issue more. But now suppose later we want to change this permission. That is where this can open and can close comes in. So I can decide whether right now my asset is open, so true or false. And then I can also say in future, can it be open? Can it be closed? Then I can give true false there also. Then we can put restrictions. And this is a very important concept here in permission blockchains. We can restrict whether other addresses can send and receive. So it is always recommended to put these restrictions so that depending upon the appropriate KYC, we can then decide who can and cannot send and receive these assets. Then we have total limit, which is what is the maximum number of those tokens which can be created, and issue limit. Every time we do an issue command, what's the maximum we can do? Then we also say how much we are issuing right now, what are the multiples. So, whether we can do the decimal points or not, like Bitcoin goes to about 8 decimal places, if I'm not wrong. So, similarly, we can set decimals here. Now, let's take an example of the asset we are going to create. So, we'll say that the category of that asset is tokenized RWA, that's tokenized real world asset. The subcategory is aviation asset, and the type is an aircraft. Now, what is the name of that aircraft? So, we are saying its model is Cessna Skyhawk 172. You may have noticed in every aeroplane on the tail there is a number written. That number is the identifier we are using. So, I've just taken a random number. Then we can say who is the token issuer. So we can say, okay, there is some Hi-Fi Aviation, they are issuing. Now, who is the custodian? Because we are talking about tokenization of real world assets, there's usually a third party government registered custodian who will keep control over the plane. Because if I bought a token in the plane, I don't want someone to disappear with my plane tomorrow. So I would trust a custodian. By the way, if you guys have any questions, just keep putting them in the comments. And don't worry if some of this is sounding a little complex, we are going to actually create it right now. Then we can put some URLs. So if somebody wants to know in detail about this asset, then they will go to this URL, which we can call as the prospectus URL. And then suppose our asset has some real-time updates, like what is the insurance policy right now, where is the asset right now, if it's a plane, where is it flying in the world. All that data can be on another URL, which we can build as part of the token itself. And then we can have a start and end date of the token. So if the token is the type which is going to expire after some time, we can put the end date. Otherwise, we can leave that blank and we can put the start date. Now, this that you see here is the command that we are going to run. Of course, because I'm talking to you guys as the techies, I'm showing it to you in the command line format. In reality, there would be a simple web page which the end user would fill up, click a button, and it would get created. But I'm showing you what really happens at the back end. So we take this entire bunch and we paste it into our command line. So first, let me show you what happens when we do that. Give me a second. Okay. So we go here and we paste this entire thing, right? So I know it looks quite complicated, but don't worry, I'll explain it to you step by step. Now, the moment I hit enter, immediately I see a transaction ID has been generated, which means this particular token has been instantly created on the blockchain. Now, I hope this is clearly visible to all of you, and I'll explain what all we have done. So we have said issue from, and then we have given this address. I told you that 1W address. Then we gave a space and we entered another address. So we are issuing from 1W to 1W also. I told you we usually issue to the same address. That's the better option, and then later we can distribute. Then we put the name. We can see Cessna Skyhawk, that name we talked about. Open, we have said it's false, which means it is not open right now, which means I cannot create more tokens of this Cessna plane. But I have kept can open as true, which means I can then go change the permission. I'll show you how to do that and make it from open false to open true. Then I can create more tokens of this and then I can again change it back. So I have this permission called can open, permission called can close, and I've kept both as true. Then we have put a restriction that send and receive is automatically controlled. So unless a particular address gets the permission to send and receive this asset, they cannot deal in it. So some of you may wonder, why do we need something like this? And in fact, in the comments, can you tell me why we would need something like this? Like, why should we do that? Let me just Yeah. So why should we give this kind of close and open and sending and restricting permission? Because of the local laws. So like let's take an example that your project is running in India and it is about tokenization of real estate, like a building. Now, as per the law, there are restrictions on who can and cannot hold property in India. So when you do a KYC and you come to know somebody lives in another country and they are not by law allowed to buy tokens of real estate in India, then you can restrict them. And that is why only people who are allowed by the law to buy the token, we can give them one by one the permission. I can see an interesting question here. Let me quickly answer that. What is meant by custodian? So custodian is like a third party. So, I don't know if you've heard of the concept of debentures. So, where a company like, say, Colgate, if they want to raise money and let's say they have a building and that is going to be kept as collateral against which they are taking a loan from the people, we call that a debenture. Now, the control of this building and the document, they go to a third party registered by the SEBI or the government in India. And tomorrow, if Colgate doesn't pay you back your interest or principal on time, they will sell the building and give it to you. So in that case, that entity is called the custodian. They hold the custody of the asset on your behalf, and they are licensed by the government to do this. I hope it's clear. If there are any more questions, just keep putting them. Let's go back to the asset creation. So we put all this send receive limitations. Then we put a total limit that okay, only 1 million can be created total. And out of that, we are saying every time we issue, maximum 50,000 can be issued. Then we are issuing 50,000 right now. One means there is no decimal place. So you cannot have zero point 0.5 token, it has to be one full token. And then all the things that I spoke about, the category, the subcategory, the asset name, the URLs that I spoke about, all of that data has been put within these brackets. So it's like a JSON data we have put. And the moment I hit enter, it gave me a transaction ID, which means now the asset is created. Now suppose I want to see the asset. So what I can do is I can hit the command called list assets and it shows me all the assets that have been created on this blockchain. And obviously for us, what is relevant is the most recent one. So here we can see all the details of the asset we have created. Just give me a quick yes if everything that I'm saying so far is clear to all of you. You've understood what we are doing. Give me a quick yes so that I can continue. Awesome. So now when you look at this, you can realize that all the different things that we put into the asset, like this name we put, but this transaction ID here, it is called the issue TX ID, which means what was the transaction ID in which this asset was created, that also we can use. So in future, whenever we want to refer to the asset, we can do it using three things: this name, this issue TX ID, or this asset reference ID. So we can use any one of these three. We spoke about the multiples that we can use. We said that open or close, we had kept it as false. So that means it is not an open asset. We cannot issue more. However, because we have kept can open as true, we will have to pass an extra command, open the asset, create more, and then close it again. Because we have the permission to open and close. Then we have put restrictions. Who can send, who can receive, who can issue. All those restrictions are in place. Then the total limit is 1 million. It cannot have more than that tokens. Issue limit is 50,000, which means every single time we issue, 50,000 units only can be created. And then all the different details that we put: category, subcategory, type, asset name, identifier, token issuer, custodian, prospectus URL, real time data URL, start date, end date. All this data has come. Then issue count, which means till now, how many times has this asset being issued? So far, only once. How much? 50,000. That's it. Don't look at the rest. This raw simply means suppose we had kept decimal places, it would have shown with that. So suppose we had said two decimal places, then there would have been two extra zeros here. But because we've kept zero decimal, this quantity and raw is the same. You don't have to worry about that. Let me take some questions. Okay. We'll go back to the command line in some time. Let me first answer. Is there any slot on turnover of the asset or company which is to be tokenized? Good question. So that is what we put in the prospectus. So instead of writing these things, because there'll be like 50, 100 things to write, what we do is we create a detailed prospectus. Like even when a new company comes with the IPO, you must have noticed they have something called as the red herring prospectus. So that is like 300, 400 pages. So similarly, for each asset that we are tokenizing, we create this prospectus. Could be hundreds of pages long. And then we simply add the URL here. So instead of putting hundreds of pieces of information, we put the URL. Hope that makes it clear to you guys. Another interesting question here is, do we always need a custodian when issuing tokens? If yes, is this okay? So let me explain. When we are tokenizing real world assets, we should have a custodian that we can trust. Otherwise, what if the person runs away or disappears? But in the normal crypto world, they don't do this, and that is why we have so many scams. But in the world of tokenization of real world assets, we always have a custodian because that is required by the law. That this is a third party who's not going to run away. Their job only is to provide custodian services. They control the asset so that nobody can run away with the investor's belonging or assets. We take another question. With this example you're giving on creating an aircraft as an asset, can you also tell all entities, companies involved in this blockchain, or have uh, I haven't understood your question. So could you explain what exactly you mean by that? Question. What is the difference between asset ref and transaction ID? Sure. So every time we create an asset, the blockchain gives it a reference ID. It's a smaller number. Issue transaction IDs, I told you every time we do anything on the blockchain, it gives the transaction ID and logs it. So that is the issue transaction ID. That what was the transaction ID in which this asset was created, and that's a much longer one. And they're distinct, they're different things. And we can use any of them to identify. What is your view on the total number of tokens to be issued? Original token holders might not be happy when the issuer okay, I'll tell you why this happens. I don't know if you read in the paper recently that in India there's a company called, I think, Seat Tires, and the price of one share of theirs has gone over 100,000 rupees, which means a lot of ordinary people cannot even buy one share. Now, in such situations, a company can split its shares and say that whoever had one share automatically gets 10 and the share price becomes 1/10, so that in future somebody can buy one share at just 10,000 rupees. So this does not make any profit or loss. Existing shareholders' wealth is not reduced or increased, but because the price of one token has gone up, that's the reason they split the token. So similarly, in the world of real estate tokenization, there may be a situation in which it is beneficial to split the token, and that is the reason we keep this permission. However, if you feel in your asset we don't need this permission, then keep it as open false, can open again false. Then nobody can issue more. So it would depend upon case to case. Hope that part is clear to you guys. Uh, okay. Let me take another question. As this blockchain is based on Bitcoin, is it possible to create ordinals? If so, how has it been created? Okay. So, to be very honest with you, ordinals is not really a real creation. I mean, it's a little complicated for me to explain it in a few sentences, but ordinals are related to Satoshis, which means you take one Bitcoin and then you split it into 8 or 10 decimal places and then you link each. But you know, in reality, they don't exist. So it's a little difficult. I'm not sure how to explain this to you, but no, we can't really do that here. And there are actually better ways of creating NFTs, but ordinals, according to me, is not the best way of going about it. Right. Could you explain how best to obtain KYC and stored on-chain, off-chain in relation to the permissions? Yeah, sure. So what we would do in this situation is, one option is we identify each address, and on the chain we mention the details that this particular address, this is the person, name, etc. Or a better approach, which I recommend, is when the people running nodes are all regulated entities, like let's say they are only banks running your nodes. So in that scenario, it makes sense to allow the bank to onboard its existing customers, and the bank doesn't have to give you any details, so everyone's privacy is also maintained. And you know that, okay, because every address is created by banks, you can trust the address. Only when in future a crime happens or a fraud happens, at that time the court can order immediately, we can remove the send permissions of an asset, so it cannot send the money away. Asset gets frozen, and then we can ask the bank, okay, you onboarded this customer or this address, give us the data behind it, and then the court case can begin, for example. So I hope that answers your question. Because storing all this data on chain will lead to way too much information on the blockchain, and that's not good in the long run. I mean, just imagine you have, let's say, 100 million users, and for each user, if you start updating their PDFs, it'll become way too much. One option is we do not do that thing, and we just keep in a text format, we keep their name, PAN number, country of citizenship. That's another way in which we can do it. So for that, we have a concept called data streams, which I'm going to give you as part of your homework to do. And there's also a video you can watch on that. So that's another way in which we can do the distributed identity management. I hope it's all clear. If there are any more questions, just put them here. Let me head back to the screen. Okay. So here, now we can see the asset has been created. Now, how about we want to update, right? So let's say we go and hit this command update. So what we have said is we want to update this asset name, and we want to set the permission which is open to become true. Now, if you look here, can you see that the open here is false? So for this Cessna ending in 8, the open is false. But because we ran this command, it should now become open as true. Now let's see whether that has actually happened. Let's sorry, just let me hit list assets. Uh, just give me 1 second. Okay. So here when we go back to this Cessna ending in 8, you can see that now the open permission has become true. So earlier it was false. Now we have updated it. It has become true. And because that has happened, now we can issue more tokens. So for issuing more tokens, we are going to say issue more from, again, we give the same address 1W, and then we are saying this is the asset. We are issuing now 2,500 more, and we are saying what is the reason? The reason for issuing, for example, token split, we would mention that, and we hit enter. It shows us the transaction ID, and we know now it has been issued. Now, if we go back to list assets, now you will notice that the issue quantity has increased. Now, earlier it was 50,000. Now it has become 52,500 because we issued 2,500. And earlier it showed the issue count was 1 because we had done only one issue. Now we have done a new issue, so it has become issue count as 2. Can you guys give me a quick yes if this is clear to all of you? There's another interesting question. Uh, Forgot to ask, but in which language are you programming or running the commands here? Sure. So I'm just running it directly on the command line. So we're kind of doing very command line operations, but you can run these commands in PHP, Node.js, almost all the popular programming languages. You can do it. There's no problem. But I'm running it straight on the command line because I'm just teaching you guys the basics. But you could use any kind of a programming language. Okay. Now the thing, by the way, yeah, it's all clear. Great. Now the next thing that I want to show you is how do we give permissions to a particular address. So I can say grant, and then I'm putting this address starting with 16. Now I'm saying for that address, for this particular asset, Cessna plane number 8, we are giving that person send and receive. So it's as simple as that. Again, a transaction ID gets generated. I have now given that person the permission. If I wanted to revoke the permission in future, all I need to do is the same command, but I will change it from grant to revoke. And then I can decide what all permissions I want to revoke. And logically, if you want, if the court orders that you freeze this asset in this address, then we will revoke the send permission. So this person now can receive assets, but he cannot send them anywhere. They are all locked. So let's move on. Now let's actually do a send. Let me show you how that works. So we have granted the permission. Now I'm going to send. So we are going to send assets from 1W to this 116, and we are going to send the Cessna 8, and we are sending 50 units. So we just hit enter. Transaction ID gets generated, and now we have issued it. It's as simple as that. Now there is no way for anyone to reverse the transaction. It's very clearly visible. Okay, any questions? Now, there are a lot of other commands that I'm going to give you as part of the homework, which you can try it out. But so far on whatever we have discussed, are there any kind of questions? Okay, there's another question here. Let me take that. What is the need for metadata? So have you noticed that whenever you do banking transactions also, there can, you need to write down why are you doing this transaction. So in the good old days when we used to have checks, we used to write down in the checkbook, why have we made this payment? Or nowadays when you do online payments, you have a place where you can write down a memo or why am I paying this money? So that later when I look at all of this, I may have forgotten why I gave the money. So similarly, the metadata is so that in future, when an audit is being done, anyone is checking their own balances, they can come to know why they made a particular transfer or a transaction. So whatever data you want can be put into them to help you understand why that money has been paid. Are there any questions? So now I hope all of you have gone through the earlier videos, you have set up your own chains, you've worked out, done some samples with the assets. Now I want you to try out, sorry, not assets, the addresses. Now I want you to try out the asset related ones. Then I'll send you some homework in which you are going to learn about how to check address balances and asset balances. And another very important thing is atomic exchange transactions. So I told you that is one of the most critical benefits that only the blockchain technology has. There is no other technology which does atomic exchange by default, and that is the reason that I've made a video on that. I want you to watch it and then you can try out those commands also. Let me just take some questions. How security is maintained in tokenization to make it tamper proof? So that's a good point. Now, in this course, we are going to talk about some of the attacks that happen on blockchains, how we secure against those, how we secure the node. So security is not a one-step process. We can look at security from two different angles. One is the technological security and one is the business point of view. So from the tech security, the nodes, the operating systems, the various commands, the permissions, all of that would come into the picture. And from the business point of view, the custodian, how the assets are maintained, all of that information also comes in. So this is a question you will know by the end of this course. How are the different ways in which we maintain security in tokenization and we make it tamper proof? Uh, Let me take another question. How can we create verification or traceability? Deepak, you're going to have to explain that question in more detail. I didn't understand what exactly you mean. Okay, another question here is how is the value of a token measured? So depends on what the token is backed by. So if the token represents 1% of a 100 rupee asset, it automatically is worth one. So suppose it is a painting we have tokenized and the painting is worth $1 million and it is divided into 1 million tokens. So each paint token is worth $1. Later, as the value of the painting goes up or down in the real world, the value of the token will move. So when we do tokenization, every asset is backed by something in the real world. So the value of the token is linked very closely to the value of the real world asset. In the crypto world, it's not like that. There is no other real world asset. So it is purely based on demand and supply. Okay. Thank you guys. Those who are enjoying the session. Awesome. So if there are no other questions, I'm going to end the session here. And I'm going to share the URL for this on the WhatsApp group. And I'm also going to give you homework, what you need to study and what you're going to do for tomorrow. So tomorrow there will not be a live session, but I will be giving you a recorded session, which I've made for you, which will walk you through this whole concept of atomic exchange transactions. But before that, I want you to do today's homework and make sure you have created your own chain and you have tried out permissions, as well as the assets before you move on to